example 6, we're going to follow the same basic technique. So as I've started all the other problems, I like to just kind of have the y equals x squared on my paper to see if it's matching. And oh, it is. I have a y start and an x squared. My coefficient's already on the squared term, so that's where I like it. So that means I'm going to have a vertical, because that's our typical parabola that we're most familiar with, parabola. Now, I want to next figure out whether or not it opens up or down. So I see a negative coefficient, which tells me that I could write myself an extra note that it opens down, so that when I get ready for graphing, I've got that extra piece of information readily available. So as we discussed a moment ago, in example 5, we're not going to fill in anything for center, radius, any of these things. We're going to jump down here to the bottom and make sure that we fill in our vertex. Now when we fill in our vertex, we're going to come back up here and look at our shifts, but we have to be extra careful, just like we were when we did hyperbolas. And we need to make sure that we always pick the x-coordinate to come first. So our vertex is going to be at 4, 6. Again, you can see the shift on the x is 4, the shift on the y is 6. Okay? And at some point here we'll get ready to make a graph, but I don't think I'm ready to do that until I have a little bit more information about where some of these other things are. So I'm going to go ahead and give myself that space to write my relationship with p. So 1 over 4p is always going to equal this coefficient, right? So our coefficient's -1/2. And so when I solve this, you want to be careful. It's not that p is 2, because 4 times 2 would be 8, and that would certainly not give us what we need to. So you need to solve this in whatever way works for you, whether it's estimation, going through the process, but you need to figure out your p-value. And that p-value tells you how you want to count. So personally, I like to do that in a graph, and you're used to that from the previous conics. But some people are more of a formula, so I'll at least discuss that way. So since it's going to open down, that means we're going to change our y-coordinate. And so if we're starting at 6 and we go down 1/2, that means we're going to be at 5.5. And again, I'd like to avoid decimals, so just go ahead and write it as a fraction. And that means we're going to count in the other direction. So if we counted down to get the focus, we're going to count up to get the directrix. So that means we're going to have a value of 6.5, because again, we're changing the y-coordinate. And since we're changing the y-coordinate, we have a y equals equation. So when I go to make my graph, to be honest, since I have some things that need to be graphed with 1/2, and the values are relatively small, I'm going to encourage us changing our scale. And so when we change our scale, we want to be very clear with what that scale is. So if I mark this as 1, and I mark this as 2, and 3, then we can see that we are counting by 1/2. We don't have to list all the numbers, we certainly can. It's a matter of trying to make sure that we've listed enough to see the pattern. Now you do not have to count the same as the x on the y, but most students will do better if they are consistent with the scale on the 2 axes. So you're going to want to make sure that you consider that along the way. So again, we can label these properly. And as you're going through this process, it's important that you remember that you've scaled it differently, right, as you're graphing. So we'll put our vertex at 4, 6. And then we want to make sure that we're going to open down with that. So we'll count down to 5.5, and we'll call that our focus. So put a little F there. We'll count up 1/2, which remember for you is actually one line if you counted differently in that scale. So when we're going to finish the parabola, though, we need to make sure that we use the proper focal chord. So remember that your focal chord has a distance of 4p. Right? And so if p is -1/2, then your focal chord length is, if you're doing this, you're going to get -2, But what you really want to understand is that since P is distance, our focal chord length is basically you're going to ignore that negative and use a value of 2 because we're talking about a length of something. So that means the distance is 2. So sometimes students will come here and they'll think that this is the focal chord. But you have to remember we're counting differently. So we have to go 1 to the left and 1 to the right for a total distance of 2. So you see that that starts at 3 and it ends at 5 under our current count. And so those two pink points represent the ends of our focal chord, and then we'll go ahead and finish our parabola. So our parabola goes through the vertex and the end points of the focal chord. And then our graph is complete.